Hello. Hello. I'm going to go here first. Hi, I'm Ren, and we're going to be building some backpack inventories today. And without taking too much time to jump into it, let's get going with the challenge, because I want to try and do it as quickly as possible. I would like to do it in 45 minutes, but it's unlikely. Might take an hour and 30, might take 2 hours, we'll see. We've got until 12, which is 3 hours from now for me. So let's have a look at this. Just going to restart my camera. So apparently my camera is just not working here. That'll be why. Okay, cool. Starting. Okay, new week, new UI. Oh, we've got a checklist here that's old as well. So let's update that checklist, I suppose. We're doing it all live. So I'm just going to jump into Photoshop, check out my checklist here. In fact, this is going to be such a small series of things that I'm not going to even do a checklist, mainly because I forgot to do it. But let's have a look at this. Let's do some planning. So first, we're going to need to sort out something that represents the slots, right? So we'll be starting off with, in fact, I actually prepared a little thing here. So we're going to generate some backpack slots, backpack slots, and those will be, 3x1, 2x2, 3x2, general shapes that we could potentially drag around on a grid. And so there'll be a default grid in the background as well. So it'll be UMG slots that could be hit tested. That'll be our base, and from there we could then make the backpack items that can be moved around. This is a game, by the way, called Backpack Battles that came out over the weekend or last week, and I played it a little bit, and someone requested that I look into it, and especially in the combat log, which we'll get to. But I want to start with the jigsaw inventory because I've wanted to make a jigsaw inventory for a while, and I have a little bit of a novel idea how it could be done. If we then create those UMG item shapes, we could allow ourselves to create interesting shapes, L shapes, long items, large items. And as you drag those around, we do a slot check logic, which would just shoot into the UI from the uniform grid locations of the item. And if there is nothing there in terms of an item, then we can check if we're hitting a backpack slot, and if we're hitting a backpack slot, we'll move forward. And so here, yeah, we've got our grid, which is going to be this. Whoa, we'll have a grid. Start with grid. Let's just say we start with a grid about this big, and these will be where items are getting slotted, or backpack slots are getting slotted into. So let's define every item that we need first before we try and explain how it works. So let's say we then have a backpack. And so backpacks can be different shapes. They could be long, they could be small. They can even be like one single item, right? So they can be varying sizes, and the same logic goes for items. So items can also exist like this, except they can also exist, more importantly, like this, and they can be rotated. And we'll get to all of that. But in the process here, let's just keep designing a little bit. So we want to define, what does this truly mean here? Let's get some large text in, and then let's get some small text. And I'll start explaining what these mean. So the grid is UMG construction script with a height and width. So you can define how many slots. So it will construct all these items, and so it's going to construct, we'll just call this grid slots, like generic grid slots, I guess, in which the backpacks can be dropped onto. So if you were to hold a backpack and you'd be off the grid like this, it would be red. If you were to hold it here and there's nothing there, it would be good. You could put it anywhere in this grid as long as we're hitting. So we could actually hover here and it would be green, but then it will snap to the closest. So we've got like a snap. Well, snap on drop will be part of this. So drag drop backpack slots, which snap to the nearest like division, I guess you would call it. Okay, and then just thinking about this a little bit broadly so that we have a good idea where we're going with it, because otherwise we'll be going in blind. Let's think about, okay, so we've got drag drop backpack slots, we've got items. So this is also a drag drop UMG. So these are both drag drop UMGs. So I wonder if there's some inheritance that we could do here, where these actually both come from a sort of a generic drag drop UMG, and that would maybe contain the logic first. Yeah, so we'd have the drag drop logic and snap in here. We would be hit testing each square to find if we can tag a UMG, I'm not sure, but to find a required UMG base. So that could be a grid, could be a backpack, and of course items can't be dropped onto items, so they will always fail. So I think this would be a smart inheritance, because then I only have to write some of this logic once. So that could be smart. Of course, we've got this grid structure as well, and we would want to ensure that everything that's generated has that same grid sizing. So if we're going 32 units, we're going 64, 128, something normal like that, then we'd be good. We'd be good to go. The thing about the item grid, which isn't really exampled here, is that these slots would actually need to be just like a little larger to some degree, so that they actually touch in this kind of way, because we want to make sure that it doesn't matter where we hover on the item, you know, if the item's this shape or whatever, that we're good, that we're gonna get a hit, that we're not missing in these gaps here. And then just thinking about that as well, when we're dragging something like this over the grid, if we're here, actually, because we're going to test from the center, so if I'm dragging over the grid here, this will still be red until we get sort of here, and that's fine. We want to be generally in the vicinity, because we're going to shoot through. And the reason I'm doing it this way is because typically you'd hold an array of all the slots, but then guaranteed you need to know where you are hovering on the grid in order to even test that array, and then you're going to grab things out the array and find out if there's space and all this sort of stuff. So I'm kind of like, well, why don't I just do it based on what is actually there? What you see is what you get. And so a little novel solution. Okay, so the backpack, again, the backpack itself is just another UMG construction script. With the height width again, it constructs backpack slots. And items is just a drag drop UMG. So let's note down our different classes that we have. So we have a grid slot. Oh, it's not letting me type. We have a grid slot. And we have a grid. So we've got a UMG grid. We've got a UMG grid slot. That is the one that backpacks can go onto. From there, we have a backpack. UMG backpack. And we also have sort of, we'll call it like a UMG workspace or something. Or it's the name of the main like panel of slots that the backpack items can be moved around in, because if it's not already clear, you have a grid that you can not really see. It's kind of transparent, and then you drag your backpack on, and then you drag your item onto that backpack, and so you can kind of have different things going on there. Why can't I control the transparency? That's kind of annoying. But we're just not going to have it transparent then. Let's color these different just for readability purposes. So that's that. This will be, I don't know, blue. It's not good blue. Let's go with this one. Okay, so wow, I can't believe it's been 15 minutes of just talking. So that's the way that is. While we're talking, let's open up Unreal. I'm gonna go for 5.5, maybe 5.4, 5.5. Good. I'm gonna go 5.4, just because that means it's gonna work in more projects that I have. Okay, yeah. So this is gonna turn into, we'll call it a workspace. That's fine. We have a grid slot that it's gonna be these. Then we've got our UMG workspace and our UMG backpack. We've got then, therefore, I guess we have I guess we could just call this a slot. I like to keep my naming conventions as well. So this will be a grid backpack and this will be a grid workspace. This will be a UMG slot. It can be hit tested against. And from this, we would have our UMG slot backpack, which is all of these little guys. Now we've got an object that can generate slots, and we've got the ability to define that this one's going to be backpack slots, this one's going to be grid slots. That means that when we're dragging an item around, we can test and be like, we're hitting something, but it's empty, so we can't go here, but we can go here. And so this will never be a slot in this case. This will be an item, so we'll have one last object called a UMG item. And this one, in order to create an interesting shape, and so let's look at our reference. Let's say we've got this banana. In order to create that shape, we need to be able to define where the blocks actually are. And we don't want it to be too manual. We could use a grid. Well, there's a thing in Unreal called a grid. And so, we may end up using something like that. But you can say, I want 3 of this, and then move them down and to the right, for example. But we need a really intuitive way of building that, so when we have 100 items, it's not so much about doing it manually. we want to jump into, say, maybe a data asset and say, oh, this is a 1x4. And then similarly, we want to say this is a sort of a 1011. So we could maybe do a text-based system where we literally type 100100110, and that would sort of give us something like this. We might do that in the UMG so it's a little bit clearer. Yeah, let's go. Let's maybe. Is that smart? Is that smart? 1 0. So let's go and make. So here we're making like this object. This is a. That's the definition for the size of that one. This is the definition for the size of this one. This might be smarter. I mean, it would be quicker than dropping something into your widget. Say you start with a blank widget and then you're like, oh, I've got a grid and then I'm gonna plop all these things in manually and click a bunch of buttons to make sure it all lines up. If it was easier, obviously that would be better. And then, so, you know, same logic again down here, we would be like 1 1 0 1, and then this will just be yeah, this is going to be interesting. This is just 1. Just going to go to games. We'll go. I think we actually have a UI streaming project. What version is the UI streaming project in? Just getting Unreal open in the background here. My UI streaming project is actually already in Unreal 5.4, so we don't actually need to make a new one. We'll just open that guy. Okay, so we're always going to need a root as well, where it rotates from. Really, we want it to rotate from the middle, but actually, we can probably rotate it from the center. It just means whenever you grab an item, it immediately snaps to the center of the grab, and then we're just rotating it. Another thing that we're not going to make today is the save data. So you would save like what is where on this whole grid, but I'm not going to do that today. I'm just going to get the logic because that's just data management, right? That's like not experimental. That's not difficult to do. What's experimental and investigative right now is this idea of hit testing, moving these around in a nice simple way to create this. So it's a drag drop UMG. It has, I don't know what you call this. Let's go and ask Super Google. Yeah, so 0.1 each config. That's cool. And so from here I would loop, I would split by each line break to give me each column, and then I would each through the returned array of indices, and I would create an object, set its grid and column. And so then I'd have this object, and then you'd have a corresponding image that would go in there. So you'd have some kind of you'd have some kind of weapon or something. So that would go in there afterwards. Okay, cool. And so this is really at the bottom. Our UMG item can go onto backpack slots. It can't can't achieve anything else on any of these others. Okay, so I'll go that way, I guess. Alright, that's our little bit of planning. Let's just wrap this jigsaw plan. Yeah, so rather than doing this with like traditional arrays and numbers and stuff, I'm going to try and do it like probably in a less optimized way. But we're okay with that. I'm okay with that. So if I remember, I had a template. So we've got this little template here. Let's make episode 3. New folder. Ep 3. I realise this is going to not work after a while, so I'm going to rename these right now. Yeah, whatever. Episode 1. I'm going to have to fix the redirectors for this. Yeah. Just do it. Because when we get to 12 and 13, it's just going to mess up. So what we do is, now that we've renamed that folder, we'll have a bunch of redirectors, which are otherwise not easy to see unless you use the filters. So I've got that. I've got this episode 3 folder. Take our template, just copy this over to our episode 3. I might streamline this at some point. We're actually not going to have a character for this game mode. We're just going to go straight into UI. So we should just clear this out. So there's no default pawn. Let's rename this to episode 3. Rename this map to episode 3. Okay, jump into that map and set that game mode. Okay, so now when we hit play, as long as we're not doing anything weird, we should just, yeah, we'll spawn. We can't see anything. Let's actually create a new empty level. We'll just save this over the top of this because we just don't need a level. We're never going to see a level. Oh great, why have you it's like defaulted to my previous stream. Episode 3. Cool. Okay, we've got nothing. We're happy with that. Let's make a HUD class. Let's start with a HUD class. So this is going to be where we draw BP HUD episode 03. This is where we're going to draw our UI. So we'll go open that up. Right. From here, we're going to create a widget, and we're going to add that to the viewport. So we're going to get the only player, set show mouse cursor, and set UI only. We'll set that UI only to whatever the return becomes for that UI, which is going to be the thing that houses our grid. Okay, so we've got that started. That's all good. This doesn't need to tick. Okay, so we don't actually have a widget, so we're going to go make one right now. So let's just make a new folder, just because we're going to folder all of this up. So this will be the core UMG here. So user interface widget will go user widget underscore HUD. Throw that in. I do like to put the episode number on this because it's going to be a lot. Compile that. Okay, so we get this HUD widget on screen. We're not actually going to see anything for now because there's nothing in there. So let's just shove some text in, and then we'll hit play. So we get that text block at the top right. That's working. Okay, there's going to be a lot of not very interesting prep work before we get to anything hyper interesting. So that's just the case of building a system. So let's just go grid first. So going back to our notes, we're going to build our grid. It's going to be made of slots. So grid can be a backpack or the background grid. So widget underscore grid. I mean, I'm breaking my own rules here because I'm not going to put episode 3 on any of these parts, but that's okay. It might bite me in the ass eventually. Okay, so we've got a grid. Grids will always be made with slots. Such a generic name, but that's okay. Obviously, I know some slots can be dragged, but we'll worry about that. Actually, can all slots be... Some slots can be dragged. Yeah, let's have a look at this. So these can be dragged, these cannot be dragged. And so I guess our extended backpack version... Actually, no, the individual slot cannot be dragged. The thing that holds... Yeah, so the backpack grid can be dragged. So that's fine. Let's get a visual in here for a slot. And obviously a slot needs to be hit testable as well. We'll go with an overlay. And we'll make that overlay visible. And we'll make our imagery underneath not visible. Or our imagery on top not visible to the mouse. And then we'll just bring this opacity right down. And maybe add a little bit of padding so it's easy to see. Now my worry is that this is actually bigger. This is actually bigger now because I think it's added to padding rather than, yeah, it's adding the padding. So that's a problem. I guess make it simple. Let's just zoom out and see how small this actually is. That's pretty small. That wrong. Let's go with that for the size of the slot. But this is a bit awkward, but we're gonna go 62. And so then we add the 2. That makes it 64 by 64, so that's good. Okay, now let's just generate a grid here. So function, generate grid. We've got 2 variables for this class, which we'll put here. So I'll just call it size, and we'll just do the vector 2D. I think that's fine. So if we break this out, we'll actually give this some values. So we'll do 2 by 3 to start with. We will, I guess we'll just seal this. So it's just the highest number. I mean, you shouldn't be allowed to put half numbers in here, but if you do, it's gonna always round up. And then we'll loop through in both directions. So we do -1 from here because we're doing zero-based looping. Go here. Okay, and before I get any further, I actually need the thing that the slots are going to go into. So we could either use, should probably use a uniform grid panel. Minimum desired slot width and height. I forget exactly how this works. So let's just like bring it into a size and then bring in some items into here. So then we just drop another one in. Yeah, so the idea here, oh wow, yeah, that's not what I want. Minimum desired slot width, which is 64 by 64. Is that gonna fix our issues? Okay, so not great. Not great. Maybe if we just go desired. Yeah, okay. So if we go to desired, we're good. And then you can imagine what I'm basically going to generate is this. I'm going to generate a shape, and I'm going to be able to drag that shape around. So let's try it. So we've got a uniform grid panel. Let's call this root, I guess. This this is non-hit testable. Okay, actually, does that say self and children? No, just self only. So, okay, because our children want to be hit testable. So we take this, we will create a widget, and it's going to be of the class slot, widget slots. Did that badly. Widget slot. Let's make sure, yeah, let's actually make this an abstract class. So back in our slot, I'm going to change this to an abstract class, which means you cannot place it, and it doesn't have a graphic. And then I'm going to create a child from that just by going now user interface widget and type in slot. So we'll have widget slot grid, or I think we called it like workspace. Double check, yeah, grid, grid, yeah, sure, slot backpack. We do need, I didn't think about this, but yeah, we did need a slot for the workspace, obviously, because they behave slightly differently. Yeah. Is there a way to make this read nicely? Whoa, where did it all go? I just deleted everything. So here, these go here. Diagramming. Okay, cool. So, yeah, we have a couple of different things. We have a slot on a grid and we have a slot on the back. Yeah, okay, cool. So that's the workspace one. We could always duplicate this and make the backpack one, but we'll maybe do that later. The grid as well. I mean, there's no real need for it to be abstract at base, but I'm going to do it anyway because I think it's consistent. So I'm going to go for that, and I'm going to make a user interface for the workspace grid. So W grid workspace. Oops, didn't need to duplicate that. Save that one. Okay. Then we should have some variables in here. Just size, 2x3. And once the construction script is finished, this will actually populate. And so, let's uniform grid panel add child to uniform grid, and it will give us in rows and in columns, which is cool. I think we might actually need to do this like this, because we're doing 2 and 3 of those 2. So let's promote this to a local variable I row, I think 2. Well, we have to decide what 2x3 actually means. So is it 2 to the right and 3 down? I'm gonna go with that. So this would actually be columns. This would be I row from avatar. And so in here now we do row column. Content is this. This is a promoted variable, which is slot class. So that can be selected. So by default, this should actually be blank because, and it also needs to be the right class. So here we go, slot, widget, slot, class. Yep, change it. This function can now take us, can we just compile that? So now it can take a slot, the default will be workspace, that's fine. Hook this in. Okay, so that should just do it. So we'll put that on the pre-construct and see what happens. One thing that we might want to do as well is clear the children of this root, because otherwise we'll just keep adding and it will not be good times. Okay, so now we've got a 2x3 grid, so that's good. Let's go like 4, 2, 1, 2, 4. Cool. A default workspace, we'll do a 4x4 grid. And so let's actually get that onto our main UI. Make sure everything's working as we go. So back to our core here, we've got our HUD widget. Let's go to our overlay. And we'll add a workspace grid. Add that to the middle. So we want a 4x4. So that's nice. Got our little grid already. So from here now we make a grid that's a backpack item, and then we can move that around here. And it would be nice to have some like drop events, and we'll have some click sounds and stuff like that. But we've got started. We're 39 minutes in. There was a lot of planning. Or I fell asleep. Or just blanked out at one point. Okay. So we have our workspace slot. Where am I at now? I need to be able to drag something over that grid there. So we need a slot for backpacks, and we need a grid for backpacks. So I'm just duplicating these children because there's no custom code in them yet. It's just visual style stuff. For that backpack grid, we just pick the backpack slot. That means it can have a different behavior now. And that backpack slot, we'll just color it a little bit. So I think we went with like a slight orange. And so what's cool now is I can make a new folder called variant, or we'll call it like backpack variants, I guess. And I could, in here, go user interface. Actually, let's just double check something. Yeah, so this is making backpack slots now, so that's good. In backpack variants, I could now go in and I could say, okay, I'm just going to make a widget blueprint here. Sorry, that is of the class backpack grid, widget backpack grid, and then I'll just do like, oh, okay, so widget underscore grid backpack underscore 1x3 or just 1x1. I could make a series of them basically, and I get to determine the look of them too. Problem is, if I want to actually do anything to the widget right now, let's actually take a look at that 1x1. And so I would set this up to be a 1x1. Let's say I actually want to do some graphics to this now. If I hit an overlay, drop that in, it actually overwrites the original hierarchy. So then there's no grid slot anymore. So what we need to do all the way back in our base class is we need to wrap this with an overlay. We can have it fill, that's fine, I think. Or maybe we'll have it centered. We'll see. And then we'll have a slot. So it's called a named slot, and this allows other widgets to put things in there. We'll do this full size, and we'll just call this content slot. now back in our 1v1x1, now I could put an overlay in here. And I could do things to this widget. Obviously, I don't actually want the color of this to shine through eventually. So this is just for debugging for now. This hit testable orange box will actually be hidden eventually. And so maybe let's just go and check out our slot. Just do a little construction script here. Branch. Call this debug. And get our little image. Oh, what have I got? What have I become confused about here? This setup needs to be in the root, because this defines like this behavior. It's got an overlay that's visible, which is just like hit testable. I'm just going to make sure that that's very clear. And then this image, which is just for debugging. So in here, we'll take that image. Can't change the visibility. We can change the opacity, I suppose. So if we're debugging, the render opacity is 1, and if we're not debugging, the render opacity is 0. And then everything should be defaulted to debug true, because the parent's debugging is true. So if we look at our backpack slot, we're good, unless we turn debugging off, and then we can't see it. Another thing that we want to do is make sure that in our default slot, we're able to set the color of this. So set color and opacity. Let's go to our designer and take some colors into our palette up here so that we have these to use after. If this is what I actually want. Yeah, cool. Default, we'll just use white. And then for our backpack slot, oh, that didn't work. We're just constructing a nice thing here. See, this is still black, which is strange. Yeah, because it's by default it's this color. So what's going on there? Oh, we got rid of the tin. Let's go and look at this. Yeah, it's so bizarre. Like, probably opacity this down. It's just for debugging. Yeah, this doesn't have a back arrow for like return to origin color, which is odd. Slot workspace, its color is fine by default, right? We would get rid of this, compile it. Now we get this, change our color. That's all good. Check out our workspace. Okay, so we've got our default grid. Our workspace grid has a new content slot, so that allows us to style it. One thing to think about here is this content slot is on top of these hit testable widgets. And so thinking about the hierarchy now, we're thinking about, we've got a workspace, and on top of that we've got a backpack, and on top of that we've got an item, and there's hit testable slots on the item, there's hit testable slots on the backpack, and there's hit testable slots on the grid. And so if I put this content slot here, and that allows a user to put like a graphic element, like an image of a backpack or a sack or whatever, on top of the grid slots, well, obviously it needs to definitely be hidden or non-hit testable, or we could just put it underneath and it can do whatever it needs to do. For not actually attaching anything in any way, so it's always going to have that same hierarchy. And that means it doesn't really matter, but logically speaking, that content slot would be underneath. And I am going to make it hit test invisible. Let's go self only, because really it should be up to the designer if they need that background to be hit testable. Generally speaking, I don't want it to be. But that might change for someone else. What if they can move the whole workspace? I doubt that will be a thing. We're trying to make something hierarchical here, so let's keep going. It's like a hierarchy of slots, right? So we've got our 1x1 now. We actually can have an overlay. That overlay is actually underneath. And so you can see we've got the orange tint on top. That just means that this can look like a backpack if it wanted to look like a backpack, which is cool. I'm not going to use this functionality right now because I'm just doing, I'm just testing. Let's just hit play, see where we're at. Okay, so we've still got this. That's just a little bit of management on all the widgets that we have there. But yeah, from here now I could be like, okay, so this is a little bit manual labory, because now I'm going to make all the different backpacks, right? Let's just make a couple of backpacks. We've got a 2x2. The reason I want this to be a widget is because I want to be able to A, see them, and B, artistically control them. And so this is a little bit nicer, I think, than like a data table. It's like not very visual, and it's a very visual game. If we look at back at the reference, it's like it's clearly a very visual game. If I was making that game, I'd want to be able to see the actual backpacks, because there's, you know, so many of them. Actually, a 4x4 backpack is stupid. Let's not do that. Let's just do a 1x3. And that'll do us for testing. We'll have those 4 backpacks. A single slot, 1x3, a 2x2, and a 2x3. Cool. And these can be rotated, right? So we'll take a look at that as well later. That's our backpacks started. We'll close all these down. One thing I need to do next is actually get this drawing, like get a couple of backpacks drawing on screen. So I'll create a horizontal box. We'll fill and center this, and then we'll get a vertical box, and we will fill that, and then we'll get some packs in. So we'll take, I thought we had more backpacks than that. Did we not? Oh, named it a bit weird there. Yeah. So we'll get these 4 in. Each bit of padding. So now when we hit play, we've got our 4 backpacks. Now we just need to actually get the logic going. So we're going to drag this. Well, we'll start with like the 3-piece, but we'll drag it, and when we're not hitting this area at the top because this one is missing, then we'll fail. We'll turn red or something of that description, and then we'll return back to the origin color, which means we have a couple of default functions that we need to write for that. Firstly, what we're saying now is that a grid can be dragged. And the question I have is, do I put the drag logic into the base grid and say any grid can be dragged, but optionally you just need to turn it on? So like a backpack, for example. Technically an item can come from a grid, but it won't work very well. So for the draggable entity, let's look at our plan that we had. I originally said that it should be sort of a draggable base class. I mean, more ideally, this would be some sort of component or interface that could be on an object. But the way that drag drop works in UMG, it has to be written in the class. Yeah, like you have to override some functions in the widget. So if you want to have a hierarchy or inheritance for drag dropping, so I don't need to do the snap logic and the hit test logic twice, then they need to come from they need to come from a base class of drag drop, which I didn't think about when I was building this. But it does sort of suggest that both the UMG grid and the UMG slot would essentially come from something that is at the very top, because of just the way that UMG cannot, well, for this particular case, it can't be, it cannot be interfaced in, it can't be inherited, it can't be like composited functionality, it has to be inherited functionality. It means that we kind of need to have a UMG drag drop as the base class of our grid. And then it could actually be the case, what item is this 2x3, right? But then we're going to like subtract away some of the grid squares afterwards, and it is also a drag droppable item. So I would want it to come from obviously from the drag drop item, but I'm also wondering now if it actually can come from grid as well, because technically it has some of the functionality of that. It has the 2x3 shape or size, but then we minus a few bits from it. Yeah. So I could override the construction script for the item to essentially say, you know, I'm a grid of 2x2, so it creates a 2x2 grid with the hit test squares, and then uses the config that I mentioned, the not1 piece config, to go through all those generated squares and remove some of them. Would that be smart? Would I just have another logic that's like, that's great. It does need to be drag drop though. It does need to be drag drop though. That is known. But yeah, let's just make a new function, I think, for the item. Okay, so we actually need to make a drag drop base class, which I'll put in core grid. I don't know. Let's just do it here. So we have a new widget blueprint. We'll call this UMG underscore drag drop master. I mean, if you're going to have a naming convention, it should be grid master slot master. Would actually be like, for me, I used to do, I can't remember now, it used to be like master, and then there was another name for like a subclass. But anyway, we want we want widget drag drop. This is going to be abstract as well. Let's go in here, make this abstract. Abstract just means you can't pick it in a workspace, in a palette, right? So if I was to come in here now and type in drag drop, I would get no options because there is no type of drag drop. Similarly, if I say slot, I can only get the child versions. So for anyone who's not following on that. That's what abstract classes are useful. You can do it for blueprints as well. So you can't place like your base weapon in the game, but also your base weapon doesn't need to have actual artwork on it. Okay, so we've got a drag drop widget. Typically, this is just from memory here, but typically this needs to be visible in order to receive the mouse hit. And then we have a couple of things that we need to override. So I'm just going to make this work for mouse and keyboard for now. But you may change, you might change this if you're using gamepad as well. It would be like, I would maybe change it to common UI and then use like on clicked, because it's maybe even easier in that sense. But we can always put mouse down, key down, touch as well, and you can kind of drag these items around. But let's do a bit on mouse down, on mouse button down, and then what we can do is detect drag. Oops. Detect drag. If pressed, we'll do this. Return that pointer event. Yep. Okay. So we're detecting a drag now. That's the start of this. If you're pressing the mouse down on this drag drop element, then we're going to start detecting a drag. Then you've got drag detected. And so from here, what you do is you create a drag drop operation. And you can define a class to put some extra stuff in there. You got some tags here that will be useful. Let's promote this to a variable, which is just like drag tag. This will be useful because when we're hovering over different types of slot, we can use that drag tag to determine like if this is good or bad. Because it's going to be good for an item going over a backpack, but bad for an item going over a workspace grid. For payload, it'll be self. Like we're going to move this whole object, and for the default drag visual, we'll also use self. Pivot, yeah, pivot center center. That basically means the moment the drag begins, that default, well, this whole widget in this case, because it's the payload and the visual, it's going to take this widget and it's just going to like snap it to the mouse. So that's good. So we'll plug that in. We might need to promote this to a variable in a second, but I'll find out. Another thing I want to do is actually put a boolean in this on mouse down and promote it to a variable called canDrag. Okay, so we have that going. And the next thing is to say, obviously we have some drop functionality as well. And we have some snap functionality. So as we're moving this object, we want to on tick, or at least on move, test underneath, and if we're hitting any grid item, we will snap to like a. We'll actually move the. Oh, we'd have to move the mouse. That's not necessarily true. But it might become a little bit glitchy if we're able to separately move our mouse around a bunch of grid slots. Let's have a look at the reference image here. The planning routing. If I've got this and my mouse is like dead, actually we'll do it from here. If my mouse is like mostly in the middle and then I get to here and then this object snaps while my mouse is over here, that would suck. If I go here, I mean it's going to be red anyway, so if I let go it's just going to drop back over. It will be a fail. It's as long as these 4 slots are good. We're not actually going to move it, we're just going to make it green. So red, green. And then when you let go, it will snap it in place. So knowing that, the only thing that I need to do on mouse move is test if the item I'm holding is overlapping a bunch of relevant plot types. So let's promote this to a variable. We'll call this drag operation. The reason for that is I'm going to use it to condition a tick on my grid. We might get an issue with this tick that every single child needs to also implement tick, but we'll see how that goes. If the drag operation is valid, oh no, so this is going to need to be a function of the grid, because the grid is the only thing that knows about the content room. Let's parent the grid now to the drag drop. And if get drag, get drag operation, that's valid. If that's valid, then we can start doing the cool bit. Get children, get all children. In fact, what we'll do is we'll collapse this to a function, and we'll call this test for overlaps. Test for slots. Yeah. Okay. So up here, we've got this drag operation. As long as that's valid, we're going to go through each of the children, and we'll get the cache geometry, get the local size, and we will get the position, translate screen position and pixels into local space of a widget with the given geometry. Turns the local top left of this geometry in local space. Local top left of the geometry in local space. Okay, well, what? How do we? So it's like local to absolute. So this will convert it to screen space. Get widget under. I actually don't remember the functionality name for this. I'm just going to do some quick research. And there's a node for like getting the hit. So you get the hit under the cursor. Get hit result at. This is for UMG in particular though. I think get hit result at screen position is just going to do an array cast. That's no good. That is no good. Oh no, there might not actually be a function for this, so this entire stream will be basically nulled by the fact that I might not actually be able to just like get the screen and then like get the UI and then hit test anywhere. Because if I can't hit test anywhere, oh god. One suggestion is to just get all the widgets of a class, which isn't too bad because they are like hash tabled, and then basically create an area for each one of those and then just like go through them all and be like, which one satisfies this this one's center trace, let's say. So worst case scenario, we're going to do that. Yeah, we're going to have to actually do that. That says get all, right, we're just going to move forward. Get all widgets of class. This, you could cache this like externally, like before this you could, in fact, already, okay. Yeah, I already have this, which is great. For the drag operation, it's got payload, right? Which I know in this particular case is a grid. I guess it might be an item. Okay, so now this, yeah, an item is going to be a grid because it has a grid, right? So we're going to cast this to widget underscore grid, and then we're going to do the same get grid panel, and we'll get all of their children. I don't think I need to get all widgets. I may need to. Let's just think about this a little bit more. All right. Got a drag operation. It could be a backpack, it could be an item, it could be anything. If the drag operation is valid, like I'm being dragged, then let's just say it's a backpack for now. I'm a backpack being dragged. I personally have a bunch of this, and then yeah, I'm going to need to go through and get different types of widgets of class. So kind of depends on what we're testing for. So here we could say rock slot class. droppable slot class. Just put the class of slot that this can be dropped. And so by default, that will be a workspace slot. Of course, this is going to be slot widget slot class reference. That didn't work. I'll compile it. Yeah, so our defaults are essentially the defaults of a backpack item. We're going to cache. This is top level only. We say no. It does mean it's going to go through everything, but it's still. Oh, it is on tick though. It'll be interesting to see what happens to the tick. At which point, you would do this. You would actually do this on drag detected. We'd call our parent, and then we would promote this to a variable called target slots. So we only do this once. We don't want to do that on tick. That would be a bad idea. And of course, we only want to do that as well if this is actually valid. Because there might be some conditions in there in the future. And there's no conditions in there right now. It's just like, if you drag it, you drag it. That's all good. Alright, cool. So, where were we? We have a drag drop widget. We drag it. On mouse down, we detect a drag. On drag detected, we create an operation. In the grid object, as we begin, we cache all the droppable slot target items. Just call this droppable slot. Put that there. Here we'll call this config. We'll move that to the top category slot class here. Cool. Then as we're testing for slots, we can get that target slot. As long as it's not empty, then we'll run this test. Because if it's empty, we've got nowhere to go anyway. Okay, so we have a bunch of target slots that we're going to look for. Payload is self, so that's fine. Now for each, bam, okay, cool. So for each one of my slots, I should probably name this. Target slots set from drag detected. And then here we're like, for each of my grid slots, test the center is within the bounds of any of the target slots. As soon as one fails, this drag is red. This drag is bad. Red. If all succeed, this drag is good. Cool. Sweet. It just explains what we're doing here. Just remind ourselves. Have to keep reminding yourself sometimes. I've just got a message that I need to check somewhere. Someone's messaging me somewhere. Who is messaging me? Good. Okay. So yeah, we are essentially going to take the local size divided by 2, which is just like, in this case 32, because we know that the object is 64, but in case you have different sized ones. So it's 2 by 2. It's this geometry, and we're gonna take the center of this. So this will be center of widget screen space, and we just need to ask if that is within, in this case for a backpack slot, is that within the bounds of any workspace slot, or inversely, if it isn't, it's a fail. Yeah, this is not as nice as just like hitting into the grid, but it is what it is, I guess. So what we do now is we get the cache geometry of this. Translates the screen position in pixels into local space of a widget with the given geometry. So if I was to say I take this and as long as this is within, as long as this is less than, oh great, I need to test both individually. I can say like within side. What other math can we do here, please? Utility. Operators. Operator. Yeah, you can't do that on there. Okay. So as long as this is, we'll always say less than, like it needs to at least be the 64th pixel. Okay, so as long as this screen position converted to the local space of this target slot is less than, and we'll get local size here, is less than the size of this or less than the size of this, and just needs to be an and, then we're good. Write that down here. If screen space of desired drop is within the local space of the target slot, it's good. Else it's bad and return early. Open this out. Okay. Otherwise return early. And so if it's not, we're going to return, and we should add an output here which is like succeeded. And that's going to be false here. And then of course if we get all the way to the end, we succeeded. Because we hit something. Wait. I just realized something. If I read this, it says we get all the uniform slots and we ask if we are within. It's immediately gonna be false, right? So what we need to do is have a local variable here, pi bound slot. And to reduce the number of loops we're doing here, we do need to break this, which is annoying. I wish there was a cheaper way. I'm not really happy with this. This is just blowing my mind about how much I don't like this. So I found slot becomes true here. As soon as it becomes true, it starts false. So and down a bit there. That's false. It's looking for a true. Branches here. If it's still false, it didn't hit anything, then we don't succeed. And the reason I needed to do that instead of returning here is because, I mean, you go through the first slot and this just returns false because it wasn't there, so it just fails. And additionally, we need to think about what happens if this object is off of all of the target slots. Yeah, anyway, so yeah, found slot is true. If found slot is true, then this particular one was good, and then we go through the next item. I guess it would be less loops, because we know our item that we're moving is like 4 items, and we know that our workspace or all of our backpack slots is like 20, 40, 50 items. Would it be less potential loops? We've got 4, we loop 1, we go through potentially like 42 slots, and then 42 slots again, then 42 slots again, then 42 slots again, potentially. Or we just loop the 42 once and we go through 4 items. As soon as we found one through the big grid, we remove it, and now we're only asking. Actually, no, because we would just loop it once. Go through every potential slot. We could phase it down by the fact that whether it has something in it, but we're not actually storing that data. You have to hit test to get that data. This is a really bad system design. The further I get into this, the more I wish I'd have done it with traditional, like this is a slot and it has a portion of an item in it, because it would now be a lot quicker to test because I can't just hit the grid. I can obviously find everything that's in my inventory quite easily because I just ask like what actually exists on the screen. But anyway, so we could do 42, say, loops. For the first one, we're checking, hey, does my item hit this? And if it does, then I can remove it from the list. And now for the next however many I'm going through, I'm only looking for 3. And so yeah, it would whittle it down. It would actually whittle it down. I'm just going to make a note for that. Could loop targets first and then reduce my slot array as each succeeds to reduce the number of loops. We'll just do this with a 2D array. We'll ignore that last part. Alright. So this is just an experiment. I wanted to see if I could do it this way. Let's keep going. I'll probably come back on another stream to do it in a different way. And quicker, because a lot of the code will already be written, so it'll be modification. Include window position. Yeah, that might be important. Okay. So now, on the event graph here, I want to do something with this, say, potential item. What I'll do is in the grid, I'll make a new function of set set drop 8, and it'll be like I'll just say valid. Go on the event graph, we'll test for slots, and we'll set the drop state here to true or false. Because of course, if we look now, all these target slots are going to return false, or it will return the last known because of graph caching, and then also this will also turn, because of, we don't want it to return the cached graph, and additionally we don't really want to return false, because if that's going to control the color, if drop state is going to control the color to be like, oh, it's red because it's bad, or blue because it's good, or at least plain. I guess for now I could be like, oh, it's successful because you're not doing anything and therefore it's just on the floor. Otherwise you could use an enum and you could be like idle, successful, invalid, whatever. But for us, we're going to do set drop state like so. That allows me to move back to our backpack. In the content slot, I'm going to create a new image, which is just going to represent our state, just for testing here. And so this will be red. So I'll be like, no, you can't do that. By default, the render opacity of this will just be 0. We will set render opacity of this based on the function that comes from our grid. So if we look here, we've got set drop state, true or false. If it's not valid, then it can be 100% opaque. Show us the red. So we'll drag that. Now, when we release the, well, let's see what happens first. First, I don't think I set backpacks to be draggable. So there is a can drag in here. Yeah, cool. And the drag tag is, it's a backpack, right? So we'll use backpack as the tag. So we get this. Now we haven't implemented any logic on here to actually collect the item, if you like. And so we will need to address for that. And also we're not getting the color. So I think what's happening is something I see a few times is like, can I please have that actually ticking? So if I put an F9 on here, see how it's not, well, it's not doing anything there, but let's go into the parent. Event graph tick, test for slots. We should be hitting this. And we're not hitting it, right? And so I think that that is just one of those annoying things about Unreal's system here for UMG. I think now it might tick. Yeah, see how it's red already. Yeah. Okay, so that's just annoying. Oh wow, its whole thing is red. Can I not? I never get a success on this. And yeah, so this one is the same, this one is the same, this one's the same. That's so annoying. God darn thing. Yeah, you actually need to. This makes me think, if I were like remembering that this is a quirk of UMG, makes me, or I don't know the way you're supposed to do it, makes me think that I would not allow you to configure each one of these, and I would do it through some sort of data, because now it's becoming a little bit thorny, like a little bit unmaintainable, because you're coming across an issue where if you forget to do this, you just get reports from devs that are like, hey, it's not working. I don't know why. And then someone's got the comment somewhere in the code that just says, oh yeah, it needs to have the tick overrode, otherwise it doesn't work. So, well, one thing I noticed, and we'll just fix one thing at a time. So, if I pick this up, the origin one is still there, and so that's kind of annoying. If we so therefore go to add grid, and we say drag drop, if a drag drop got detected, I kind of want to set visibility to hidden, because I don't really want you to see the origin. There are technically 2 of them right now. And then we have like drag, called using drag drop when the mouse is being dragged over, drag over. Yeah, drag cancelled here. Obviously I want this to come back to whatever it was, which, because it's a draggable item, it needs to be visible. So that sorts that out. There is another event for drag. Perfect. So like drag complete. Event drag. Maybe it is just cancelled. Nope. Oh wow, yeah, and it also hides the one in my hand, because that's helpful. Gosh darn it. How annoying is that? So you'd have to create a drag visual. Well, you'd basically need to duplicate the UMG, which is just kind of sucky. What do I want to do with this problem? So I want to hide the one that I'm moving, because I'm moving it. It's the payload. Default drag visual. What if I don't make a default drag visual? Can I just drag it? Let me drag it. It says backpack. I love that it just says backpack. Normally, people create a new widget to represent the temporary drag. No, I want to drag this entire item. Thank you very much. I've done it before. Don't know why it's a pain. It seems so weird to initiate a drag and then like create a whole new widget to represent the drag so that I can hide where it came from without it hiding my own item. Let's have a look. UMG drag drop. We can make this set. Script. Let's just get this base logic working before it hits the hour. Otherwise, this stream just like not great. So let's just create a new widget. We will get class of our self get class. That's the widget we're creating. We'll promote this to a variable temp drop. So drag visual. we will need to remove that from parent later, essentially when this happens. So here we'll create this. This will be our drag visual. What? What's going on there? Drag visual. That will be our visual. We will then hide ourselves. The only sign of progress is working content. So let's just move it. Happy days. Interestingly, it looks like the drag visual does not run. Well, I guess it's not running the tick because it's hidden. Also, like, if it is ticking right now, yeah, I guess one thing I need to do is clear the grid. 1 sec. So go back to the grid, go here. Target slots is true. Drag drop operation should have been false by that point. Debugging mode failed. Debugging mode failed. Awesome. Okay, so I drag this, drop it here. Debugging mode failed. Well, Unreal's not really happy with me today. It's really not happy at all. Okay, well, we can go here. Stop. Play. Drag. Drop. It's still valid though. Well. Not sure. Put print in here, I suppose. Not letting me, it's not letting me debug that, so we're just going to put a hello in there. As we drag this and drop it, we're not getting the hello, which means we are exiting, which is good. Don't need this right now. Don't need this. Don't need this. But set drop state. Not bad, it's visible. Yeah, sure, cool. That's what we want. Wow, it doesn't even want to debug that. It's crazy. What if we say, if this is not equal to get render? I'm trying to make it debug for me. Get render. Let's see. Have a look here. Oh, this. My mouse just keeps disappearing as well. Okay. Is this equal to mouse, please? Jesus Christ. Jesus. It was name in vain every single time by accident. That's okay. Play. Drop. Okay. Supposed to debug it. Bam. Drag, drop. I'm pretty sure that in the parent drag drop, when I'm setting the visibility to false, the tick stops happening. So what we'll do instead is we'll set the render opacity to 0. And that will retain the tick. We'll remove the drag visual. We will set this back to 1 if it was cancelled, or complete, ideally. drag or just on drop event. Where's that drop? Called when the user is dropping something onto a widget, ends the operation. Yeah, I don't know. That's bonkers. It's not going back to normal because now it should be. There will be targets because we didn't clear the targets, but there shouldn't be a drag drop operation because it got cancelled. So does it not like fully get cancelled? Do you actually have to clear it as well? Yeah. So apparently the drag operation continues to exist after it's complete. So I don't need this hello anymore. Another thing that's happening is when I create my duplicate here. So if I go here, when I create this UMG drag drop widget, so let's just do that. Boom. It's created a 1x3. But then I guess because this drag operation doesn't exist, it doesn't tick. And so what we'll have to do is add a do hit test exposed variable here. And we'll refresh this, and it's like this one does a hit test. And then in our grid that does this, we'll do hit test. So that'll be our new condition instead of the drag drop operation being something. But as you can see, that did nothing. Did absolutely nothing. You're supposed to. This one is definitely supposed to do the hit testing. Widget grid backpack. Oh, I guess. Yes. I guess what I need to do is over here on, not here. Where did I do this? In the drag drop detected, I get all these widgets here. So I'm going to need to do that somewhere else because, as I've realized, that is not that is not being dragged actually. So class function init individual, I guess. Nice. Okay, so now we're getting something. Now we just need to know really what I should really do is, instead of setting this entire backpack to red, I should just set the items that aren't hitting to red. Would be nicer. So what I'll do is, in the backpack, in the set drop state, I'm just not going to do that. And instead, in the UMG drag drop, in the grid, the test for slots. If this succeeded, I'll promote this to a local variable. I load slot. Color. Not gonna work. It's just a widget. Okay, so we'll paste it to color opacity to this is just, again, this is just testing. Let's set this to red. See how that goes. About 2 of them are good. 2 of them are succeeding. How weird. How strange. So our math is like totally wrong. Translates the screen position of pixels into local space of widget with given geometry. Okay, maybe that 2 box was important. Nope. All right, what's going on? Let's have a look. Local size. See, this should be. Let's just hit. Maybe the numbers. Oh man, I have the information because I just want to know. Got target slots here. I can't even debug this. See actually how many target slots it finds. It should find a good number. Yeah, okay, cool. 16 of them. Awesome. That's the workspace slots, which is what we want. Do absolute to local. What's the absolute coordinate? This one. Is this less than or equal to essentially 64 by 64? Why are you green? Why? Found slot. Found slot should be false. Maybe I can just come in here and be like, it's also false here. Doesn't make sense though. We should only need to set this to false here. Because what we're saying is, I've got 3 slots that I'm going to check to see if its center is overlapping the area of one of those items, and if it is, then it's found, it comes through. If it's found, it's green. Yada yada yada. Can I need to like debug point? Yeah. Well, I'm going to try and draw a debug point like in screen space based on this absolute position. So we'll go pink for 1 second, size 5, project, deproject screen to world. What's the world position? What's the screen position? Cool. Yes. Local sounds. Go. I know it's 32 units, so we'll just skip a little bit of math quickly. Is that gonna work? Can't see anything. Get any debug points, which is bloody annoying. No position plus direction multiplier. Maybe it's just a case of it being like so close to the camera that I can't actually see it. Try that. Let's try doing like a 500 unit debug point. Ah, it's in the top left there for a second. Wait, are you seriously doing this? Oh my god. It works now. It works on my other monitor. So it works on my left screen perfectly fine. It's because my window's all the way over here. I'm just gonna debug that online because that's wild. Maybe I'll do local to viewport. Maybe that will be a better... Maybe we'll have a better time with that. So this one will be abs to view. Local to viewport, great. This isn't gonna work. At least this is now debugging in the right place, so that's handy. I don't think the rest is gonna work though. I mean, it's all green right now, which is obviously wrong. And so what I want to do next is take this into here. I want to draw... We've got local to viewport here. Yeah, let's do that again. We'll take this and we'll just take 32 by 32. We'll just do 5 units. That viewport position, please. Okay, well, that didn't work. Player controller 0 to this. Why? Do you just not like being so small? Yeah, so that's weird. It's yeah, strange. Let's actually take the local size here. Divide that by 2, actually put that in there. That's I guess is that the center? It doesn't look like the center at all. And also, you can see how some logic is working somewhere, but it's not in the right spaces, the right screen spaces. Is that cube coming out of the center of that? It kind of looks like it is. Can I say like 32 here? Makes no difference. This one's selected. It looks like that cube is starting at the center. Does it? Kind of. I mean, I guess you could say do 50 and then just we can't do anything else with that. Let's just leave it as it is. Okay, so whole screen is just like green until the top. So there's definitely some math that's completely off somewhere. But once this works, that's kind of the base of the whole puzzle. Then we take load to viewport, local to viewport, screen to viewport, but no reverse. Why? Okay. I'll try something for a second. Yeah, here. I'm actually going to do this on my other screen. Yeah, I'm an idiot. Wearing local to absolute coordinate. Wait, what? No, I don't want that. I just want local here. This one, thank you. So I guess this, yeah, this could be so far. So maybe I should do a distance check. Yeah, I think a distance check is going to be better. Okay, so I think what's happening there is it's obviously less than could be like minus, so a bit of a problem. So we'll do distance. So can I just do distance 2D? Essentially, what's the distance of the center of this in, I guess, in viewport space? Well, we know all this is working. We don't need these two bugs right now. That's fine. Local to viewport, don't need that. Local to viewport, don't need that. Local to absolute, sure. So center of this, we'll promote this to a local where I center of, what do we call this? Local slot. We'll just call it I center. That's the center that we're testing. Against this, it needs to be a distance. Ooh, how does that work? It's half of this. Possibly. Going on now? Now the other two just don't debug at all. What? What? Do them in the same space at least. Okay, so you can see as the center of the cube goes over the grid slot, we're good. And as soon as it goes off, we're bad. And so then this would be a valid drop, but like when there is an object on there, it's going to be occluded. And so then we can't drop an object on there. And it's kind of nice. Okay, so one thing that's happening though is as I go off the top here, I guess we're returning false here, but we're never setting the color of all the other slots basically, which is not great. So we should probably do that. probably come in here, do this, set this to false like so, and that. There we go. Oh great, so only when the top one... Yeah, it's because it's returning. If the top one fails, the rest of the logic doesn't go through. God damn it. If the top one fails. Okay, fine. We just won't do this. We just won't return. We'll put a little red in here. Red. We'll also have like another local, which is I failed. We call it I success. And that just becomes false here. It's true by default. And then on the return at the very end, we just have I success. Doop doop doop. Cool. Boop, boop, boop. Sweet. So green. Okay, so this is looking good now. Finally. Okay, so the next thing is that when we drop the object, we attempt to like snap it over. Okay, so we're going to try and move it over into the slot and actually lock it in. Okay, so how do we want to do this? I'm going to try and set the position of this widget. Now to the slot. Yes, it's a difficult one in some ways. There's no definitive route, so we have to come up with one. Because we're coming up with one is good because it means that when we save our data, we know where we're drawing everything from when we redraw our UI. So I think could really just be top left. Then I've got to determine, because we can have L-shaped backpacks, for example. Because this is the same logic that's going to be used for the item logic. All inherited. If it's an L shape, top left would be good. Yeah, okay, cool. So we would just get the first child Get child at. We would just get child at. We would come in here. We'll say target snap slot won't be an array. It's null when we come in here. It gets set here. If it's not valid, the first entry to set it will make it valid, and then we'll do this as well. And so the idea here now is, rather than doing any other bunches of booleans and operations and stuff to check like, are we index 0 on here and therefore like I do this stuff, we're just saying, hey, when I'm determining if I can move, then we're going to clear the snap slot until we've dropped, at which point this is true, so this will still be valid for when we drop. If it's not valid, we want to set it, and it will be setting to, I guess, let's go up and over. It's going to set to this. And from there, we are almost clean on code. Pardon me. Oh, I hate this, so I'm just going to promote this to I target slot. These locals around so it reads a bit nicer. Okay. There, get rid of this to keep it cleaner. Yeah, so then we take this and we kind of run this logic again. Oh no, because we know the target slot now. So we just take that target snap slot. We just set position in viewport, because these are kind of added to the viewport. We just get this, get cached. Are these going to be added to the viewport? Yeah, they're technically going to be added to the viewport. It's a bit weird. Apparently they're added to a vertical box. So I've got these backpack slots that are all added to a vertical box. Yeah, that's a pain in the ass. Anyway, so because I'm now gonna go set its position in the viewport, but that's not gonna work because it's not added to the viewport. So what you could do is like remove from parent and then add to viewport like immediately afterwards, and then set position in viewport. Oh god, this is becoming really bad because it's not parented in any way. So if you move that backpack, like the items are not going to move with it. And so what you could do, instead of adding it to the viewport, I suppose, you would remove it from the parent. So that removes move backpack from whatever. Instead of adding it to the viewport, what we're going to need to do is every grid is going to need to have a canvas panel. Put that sort of in between, and that will be full size canvas panel underscore grid. We're going to need to add it to here, like with an offset basically. Okay, so we cast this to a grid, I believe. It's a slot whose parent is a grid. Get owner. Oh, what? Oh, parent. Yeah, it's like get the parent's parent. Cast that to the board. I can't do that. Get the child here. What's this to slot? Yeah. It's not to grid. What? Why is this not working? Oh, it's outer. What am I about? Being a fool. Yeah, outer. That's to grid. Okay, get canvas. Okay. Click in. Add child, it's self. So we remove ourself and then we add ourself to the canvas panel of the grid that we're moving to. The reason that was important is because we need to be able to do like local based position sort of offset. Using wait, so it's target snap. Yeah. Oh no. Wait, what am I doing? This target snap slot. So whatever grid you're part of, and in this case it'll be the workspace grid. So we're gonna add this backpack in this case to the workspace grid. And so you might be adding an item to a backpack as well, is another thing that you could be doing. I'm going to add it in the position, attached geometry of this and this. We'll do, actually we'll copy this over here. What we're going to do is we're going to pick, can we do this here? Panel slot, set position. No? Set position. Set widget slot position. Okay, cast it. Wait, can I just add child this panel? Yeah, cool. Self and then set position. And then from there, what we can do is we can find what like offset on that canvas was the slot that we're going into. Because for example, we could have slotted it into this L shape here. This is the first slot. This is the position that we're going to move our like L-shaped item or backpack to. So what we do is we get this. We just want to get the position. Get local. Get local top left in local space, which is I just find this hilarious. Returns the local top left of the geometry in local space. That is 0, 0. We'll do absolute to local here. Or do we just... Curious if this is local to the widget that it is fully in. So we're actually just going to try that first. Okay, so now I'm going to take this logic, and that's going to be for our... when we drop a drag drop item. And it's valid. I think. So the only thing that I want you to be able to drop onto is a slot. And in fact, in that case, if the only thing I want you to be able to drop onto is a slot, then I could add this widget to that slot and then just not call the geometry of the widget once it's added to that particular slot. It would mean that you no longer have a canvas panel that is just all of your items or backpacks. But it would make this quite clean because I wouldn't need to set position or anything. I'm just adding the child directly to the object. But then it will expand the size of the slot based on the child geometry, unless you have a size box for the whole widget. I'm going to carry on with this method. One thing I've realized, just thinking there about hierarchy, is actually my slots need to be under my canvas panel. You know, like we'll call this for the canvas panel slotted objects or something. And so this needs to be above because it's the thing that's going to stop the dragging from hit testing occupied slots. And so yeah, there needs to be a function for like on drop occurs kind of on the slot. But on drop also occurs from like when you release your mouse key. And because if I actually, there's a little bit of a problem. I'll go and evidence it now. But this one, for example, when you pick this up, you'll see how the center is hit. When I drop, there's no definitive object like under my mouse right now, and so using the top left element is the best idea. And so on drop isn't gonna work. I think it's counted as on cancelled when I let go there. And so what I could do is I could go and take a look at our drag drop widget, and I could say, okay, event on drag cancelled, set the origin to this, remove the drag visual, stop the drop operation. I could continue that logic on cancelled here. Add call to parent function. If essentially at this point, if target snap slot is valid, then I'll run this logic here. See if it works. Didn't work. Immediately just didn't work. So drag it, drop it, didn't work. Okay. Why is target snap slot not valid? Go forward. Oh, wasn't valid. It's not good. You're supposed to become valid right here. Target snap slot. Again. Whoa. Debugging failed, sure. Play. So the interesting thing now is yeah, I did need to do some slightly better logic in here. So that's it. So let's actually go and do some that logic I said I could avoid, and I can't avoid. So I'm just going to do it. I'm just going to write it. So this is just promote to local variable I slot. Do that right? No, I didn't do that right. Right, so local I local slot. Here, okay. Okay, so if we found a slot and our local slot index is equal to 0, then it's our top left slot. And if we don't already have an object, well, that doesn't really matter anymore. We're just going to set it either way. And if it's not equal to the first one, then we do want to actually go back. Okay. Again, seriously. No, but iTarget slot is definitely something because you're looping it, so you should be fine. And then oh, interesting. Huh. Yeah, target slot is never valid. I keep forgetting this. So when we cancel the operation here, we need to cast this to get payload. Has to drag drop operation. No, payload is cast to drag drop widget. Get target. Get snap. Oh, come on. Oh, right, okay, because it's a grid cast to grid, I guess. It's not exactly great so far, actually. I would move some of this stuff. Get snap slot. And question if that's valid, because if it is, then I'm just going to go set it and then move forward with this logic. Yeah, I keep forgetting that the visual and the actual thing being moved are not the same, so any variables you save during the hit testing are not available to the actual thing being moved because of some stupid logic that I may be performing an oversight on. On to, yeah, debugging failed, yeah. Drop. Oh, come on. Let's go here. Is the thing valid? Seriously, it's not. Huh. The payload already. I think the payload's already been removed from the parent at this point. Payload is a backpack slot. There is a grid. Target snap slot is unknown. Snap slot is unknown. That's weird. We're dragging an object. We're testing for slots. This is only true for the hit testing. When it's being dragged, right? Let's just not do that then. Oh no, that's not good, because we could go here and then go here and then release and it would be true still. So this has to get reset. I wonder if the issue is that I need to do this just in a certain order here. Although it does make more sense to be in that order, so we'll keep that. Just suggesting like, hey, don't clear everything until we're done. Yeah, in the parent cancellation, we haven't even called this yet, so drag visual. Oh, that's true. The grid, I can just get drag visual. That's that here. Oh, payload was self. Again, another bloody thing that's annoying. We should definitely do this in this order. Okay. Okay. Bam. Cool. So it is there, but it's not. The draw size is wrong. Oh god, I can't remember the name for this function. Is desired size. Set size. Set auto size to true. Okay. Click here. Oh, come on. That sucks. So it's supposed to hit. Yeah, and then this fails, so we're not allowed to do that. Although we could say that if we're failing, we would just return it to the pool. We're getting close. So there's an issue there where my original intent was that it would hit test. It would hit test and hit the visible geometry of slots. However, because we're not hit testing now, because instead we're just saying, is my space in the space of the grid by distance to the center? What's happening now is you are not hit testing against what was intended, like visible item or backpack that's in the way of the workspace grid. So I need to. It's getting to the point where storing it in a 2D array obviously is a smart move, because that is a better way to data orient the state of all grid slots. Which would just be. I mean, I don't think you can do a 2D array in Blueprint, and also the challenge was to do it through this method. So, it is a shame that you can't just ray into the widget. Graceful widget by screen location UI. Graceful UI widgets by screen location. You'll need to convert screen coordinates to world position and then use a line trace. No, that's not going to work. That's only going to work for widget components, because you're line tracing by a channel. So that's not going to work. How to trace for UI widgets? Maybe this person asked this question. It's doable in Blueprints. Okay. Guys, it's doable. Thanks. I don't know what options there are at the game level. At the slate layer, you can use find child under mouse. Find under mouse. Under mouse. Uh-oh. No. Find. Just the word find. Does this project have the word find? It does. Okay. Bubble path. Bubble. So you could do it in C++. This method that I'm doing right now, where I want to find if there's a hit underneath, is I just call find child under mouse on the workspace grid, and it will just give me that last element that's being hit. But it is only under the mouse, so that still doesn't really help. But then I could go in and I could look at how that's being done positionally, and then I could make a C++ function that's like neat. But yeah, the reason all this is important actually to some degree is that even if I did have a 2D array and I was moving my object from sort of my library, and then I was putting it over my grid, I would still need to know where all these slots are, which I guess you could still do through math, because you know where your mouse is, you know that your drag object is centered, so you've got the XY center, and from there you also know where all your grid items are. And so then you'd just be like, and what's the nearest slot to each of these positions? That's the center of each of those. And then somehow go through your 2D array and like pull those ones out, and then ask if there's anything in them, and then do some more logic. Which is why I wanted to do it this way, because I was like, that sounds really verbose. To have to go through all those when you could just be like, well, there's a physical thing that we're moving, so let's just use the locations of the physical things. And so yeah, now I've just got a problem that's it's solvable. It's solvable. So when we're testing for slots, we let's go back to init drag visual here, droppable slot class. What we also need to do is get hold of anything that we're not allowed to land on. So what we could actually do is just get all slots and just call this slots. Perfect. And let's go tag up our slots now. And so let's go tag up our slots. We've got slot for a backpack and slot for a workspace. Our slots are going to need some sort of tag on them. Is there a tag just by default? Is there a tag in the class defaults? Is there a tag in the settings? No, so we have to add tag. So we'll just give it a tag. It's just a string that goes in the slot. So for the workspace slot, our tag is going to be workspace. Workspace. For our backpack slot, it's going to be backpack. It's all good. When we create the UMG drag drop, our desired drag tag, we're going to change this as a default to workspace. Workspace. And then we'll go check our. So we're dragging a grid. Yeah, so let's go to our grid. To our defaults. Yeah, desired drag tag is workspace. Cool. For the grid. There. What about our backpack grid? Less defaults, please. Where are these different again? God damn it. Workspace, cool. Okay. Need to sort out all of these variables. It's kind of annoying. So now when we're doing our yeah, so this is good. So it's going to get every slot, and then for test for slots in here, what we can do is as we go through all slots here, we get tag. We just want to do this. Wait, what is this? It is a slot. Get tag. If the tag of the slot is equal to equal is equal to the desired drag tag, then we can move forward. And so now this is getting into that like hierarchical sense where it's like this one can be dropped onto this, but it can't be dropped onto that. In another alternate version, you could have this as an array, but I don't think it's necessary. So here we go over here. So that's not good. I'm not actually retrieving everything, which is slot. Let's go and look at our backpacks. So we've got backpack grid. Backpack grid is supposed to create backpack slots here. Oh, droppable slot class was a workspace slot. Which actually is just a variable that we don't need anymore. So we just get rid of it. Grid backpack, class defaults, backpack, it's looking for workspace. Ah, right, yeah. God. Okay, so the idea was you can check, and if it's valid, if it's valid here, like in terms of the location, check if it's actually the desired tag, because if it's not, but you are sharing a location with it, it's not good. You can't go there because there's already something there. Just all in the absence of being able to test the geometry in Blueprint. I could have done it in C++. Might be a good reason to go and learn C++ just to play with this idea a little bit more. I can obviously read and write with it, but I can't just without some resources open. Target slot tag, desired tag. Okay, if it's not, if we're not good, then we need to like return back. Okay, so success here. So this is good. And so now I actually want to do this. We've actually broke early here as well, which I'm not gonna be allowed to break early anymore, because that might mean that we miss checking up on a lot of another type. So we can't do this. We can do this, and we can set this to false. And we can come here, I guess, and be like, hey, if we're already not successful, don't allow us to go through. So don't find slot if we're fire overlapping non-desired tag. It's a little bit messy now. We've got to the point where it's a little bit messy now. So we come in, we have a bad time. It's because it's finding itself. I've realized. Remove. I can't remove items like that, but I can't remove items like that, but I can go into our grid, get all children. Why not remove like this array? Arg! You can't remove. Can't subtract. Array. Array, reverse, resize, remove, shuffle, shuffle, swap, insert, yeah. Append, no? Okay, cool. So we just need to each loop through our slots and remove each individual element from all slots. Remove item. Like so. Oh, come on. You need me to cast this now? Blah. Okay. So that's all good. Hit play. Yay. This one, bad. Can't go there. Drop it, not good. Here, sweet. Here, sweet. Here, not allowed. Oh, ha! Still let me anyway. Seriously? Well, now I can do it anytime I want. There's a bug in. There's a little bit of a bug in there. But we've got 9 minutes. We can fix that. Maybe. We can maybe fix that. Huh. How do we fix that? I wonder. How do we fix that? Okay, so first reproduce the problem. So I can put it in, put this in, put this in. I could put this in. Which means that the top left one was valid. It just means that if we get here, we need, well, it was not a success. Anytime it's not a success, we need to clear it. So basically down here, if it's not a success, well, yeah, I don't need to do this everywhere. I can just be like, at the very end, if it's not a success, clear it, and then just return false. If it is a success, just return true, sure. It's a bit of a silly boolean, but it is what it is. Okay, so an easier way to do that would be to just put this here. But we can reproduce the whole shebang. So we'll put that there, we'll put this here. Yeah, cool. Okay, so we're at a point where we've got my first ever jigsaw inventory based on the actual positions of these items, which is super cool because rather than having to have all this complex math about like checking all the positions that you could be in, are they free, are they, you know, whatever, you're just literally testing against like what is in those spaces. And that means you can have like O shapes, like you can have a moon, you could have like a wheel that has a hole in the middle that you could, if you wanted to like organize your inventory, you could just like stick a little bag in the middle there. And then from here you can make other stuff, like when I click on this object, it's actually a bag and it just opens up a whole nother bag with its own interesting shape. And so one thing to think about here is that this is hierarchical. So if I was to have a couple of items on the right side, in fact, how long have we got? We've got a couple of minutes, so let's go make some items. How do we do it? So we do grid, but this one is for an item. We do a slot, but this one's for an item. So you should be able to slot items, but only onto backpacks, if that makes sense, right? So this one takes items. We're just going to do we'll do 1x2s for our items. The desired tag here is backpack, and it can be dragged. And then we go to our widget slot item, and we double check the variables on here. So the tag is item. So I don't think you'll be able to go further than item. Like, there'll be nothing that can slot onto an item, right? The debug color for this is just blue. Then let's go new folder item variants, and we'll come in here and we'll go user interface item. We want the slot for items. We're doing this, I think it's slot item, maybe? I might be, no, I'm wrong. It's a grid. It is a grid. So widget, items would have an additional, the 0-1 config thing that we spoke about, but we didn't get there. Item, so you can make like L-shaped items and stuff. So grid item underscore, or we'll just call this widget underscore. I think it was just like 1x2, right? So if we were to open that up, yeah, we've got this 1x2 item. Back in our main HUD here, let's copy this vertical box into the horizontal box, and let's replace this with just like four items. And obviously this is annoying, and you wouldn't do this for very long. 20? Was it 20? Sure. Okay. So I should be able to like drop this in here. Try this. It's like red. I'm not allowed to drop it in there. I should be allowed to drop it there though. Interesting. I guess I didn't respect that. But I guess actually, what did I miss here? So we go through all the slots. That's the workspace slots and the backpack slots. If we are hovering like a workspace slot, and it's not what we want to be on, then we should fail. Just outright fail. Because I think what's happening is we'll find a workspace slot, that's false, it's not a success, it will now never succeed. There may have been a workspace slot on top of that we could have used. It's basically as... Oh, okay. So we could do it where we test to see if the tag of the target slot is equal to like our tag. Which is just going to be a pain in the ass, but basically it's this, and then we just convert this to pure, and we just get the tag of this, and we say, hey, is it the same? We can actually keep this here. Is it the same? And if it is, then success is false. Otherwise, we'll just do this. Which might mean it's now going to like flicker, which is not good. That goes on there. If I go like this, yeah, that still broke. So that should be green. Green. Obviously, it can't go there. So it's not allowed. But yeah, oh, ha, you know what? It's a bloody thing. Tick, tick. Tick, tick. Come on, tick. Tick. Thank you. Can't go there. Can't go there. Can I go here? Ha, look at that. I can just slot it in before I move it. Amazing. Again, this isn't working over here. This is working. This is good. This is bad. This technically green, also not good. I guess what I need to do is, in that case, is length here is a little bad, so we'll go like 2.25. So now if I go here, oh no, it's still good. It's not good. Let's just do this like minus some padding, like -4. Is that going to stop that? Anyway, there's a bunch of bugs. Oh. Technically, center 2 items, but that will never be the case on an actual grid. You shouldn't be able to drag these into here. Oh god, no. What happened there? That's not cool. Why would it be offset? Why? Why would you? Oh no, that's also not good. So that's bad. That's bad. That's good. That's good. Oh, now all the bottom is bad. Okay. Wow. Yeah, I really messed up something here. And then another thing would be to make sure that this is a little bit smaller enough that you can actually grab the backpack. See, this should be good here. That should be good. But we can fix that another time. And we kind of got to a point where we realized, like, there's got to be better ways to do this. And so it's just a thought experiment around, can you make a backpack inventory, like a jigsaw inventory, based on checking what you see is the data that you check against. And it turns out it probably needs some C++. So we'll leave it at that. And that is an episode of experimenting. I hope it was valuable to someone. A bit of a long one. A bit of a fail at the end as well. I think we didn't really get something usable, I would say. But we did learn a lot. So that is the key. And then I will be back later this afternoon to do some more streaming, where I'm